Good afternoon, class. Today we will discuss section 9.2, comparing two population means when sigma is unknown. And this is a typo here. Of course, we're talking about 9.2, not 9.1. So in this section, we will once again look at confidence intervals for the difference between two population means. However, we will now consider the case when the population standard deviations sigma 1 and sigma 2 are unknown. Since we do not know the values for sigma 1 and sigma 2, it might be the case that they're equal. In this case, the sample variances can be pooled or combined to give a good estimate for the common population variance. For the purpose of our class, however, we will not discuss this scenario. So we will always assume that sigma 1 does not equal sigma 2. In this case, when both population standard deviations are unknown and assumed to be unequal, the samples taken are independent, simple random samples, and either both sample sizes are at least 30 or both population distributions are approximately normal. The margin of error of a confidence interval for the difference between two population means is given by the following. Notice that this looks very similar to the formula we saw in section 9.1. However, our z-value has now changed to a t-value, and our sigma 1 and sigma 2 values have now changed to an S1 and S2 value. Since we are using a t-value, we need an idea of a degrees of freedom. In this case, the degrees of freedom will be the smaller of n1 minus 1 and n2 minus 1. So what we do, we now have two samples. We're going to subtract one from each sample and use the smaller value, right, the smaller value for our degrees of freedom. Let's look at an example. Dentists believe that a diet low in sugary foods can reduce the number of cavities in children. 10 children whose diets are believed to be high in sugar are examined, and the mean number of cavities is 3.0, with a standard deviation of 0.7. 12 children whose diets are believed to be low in sugar are examined, and the mean number of cavities is 1.8, with a standard deviation of 0.6. Construct and interpret a 99% confidence interval for the true difference between the mean numbers of cavities for children whose diets are high in sugar and those whose diets are low in sugar. Assume that the variances of the two populations are unequal. We first notice that we have two groups given in this problem: children whose diets are high in sugar and children whose diets are low in sugar. Since children whose diets are high in sugar are mentioned first, if we go back to the problem, notice that we have a sample of children whose diets are believed to be high in sugar. This group is mentioned first. We will let population 1 be the children whose diets are high in sugar, and population 2 be the children whose diets are low in sugar. Again, this will help us with our notation. So x bar 1 is the sample mean for children with high sugar diet. Mu 1 is the population mean for children with high sugar diet. And S1 is the sample standard deviation for children with high sugar diet. Similarly, x bar 2, mu 2, and S2 are the sample means, population mean, and sample standard deviation for children with a low sugar diet. We're going to follow our three-step process. So first, we want to find our point estimate. We're wanting to estimate the difference between the means. So we look at x bar 1 minus x bar 2. Now notice in this problem, the children whose diets are high in sugar have a mean of 3. And the children whose diets are low in sugar have a mean of 1.8. So x bar 1, which is high in sugar, mean, minus x bar 2, low in sugar mean, gives us a value of 1.2. We next need to find the margin of error. Now notice we're using this formula because, why? We see a standard deviation, but they're not telling us assume the population standard deviation. Notice that from this sample, we've calculated the mean and we've calculated the standard deviation. So because that sentence is put together, we're assuming that this standard deviation is still coming from this sample. So this is our S1, and similarly, this standard deviation is our S2. So we have our S1 and our S2. We've sampled 10 students whose diets were high in sugar, and we've sampled 12 students whose diets were low in sugar. This is our N1 and N2. And our T alpha over 2, our confidence level was 99%. Remember, when we're finding our T value, we can't use this confidence level directly. We need to take the complement. Remember, the complement, alpha, is 1 minus this value. 1 minus 0.99 gives us 0.01. So we use an area in 2 tails of 0.01, and then we needed degrees of freedom. Well, our 2 sample sizes are 10 and 12. If we subtract 1, we get 9 and 11. Which one's smaller? 9. So our degrees of freedom is going to be 9 in this case. When we line up a degrees of freedom of 9, an area in 2 tails of 0.01, we get 3.250. So pause the video and make sure that you get this value. Again, a very important part of this problem. Plugging this into your calculator, we get an error of 0.913476. Finally, piecing it together, we take our value in step 1 and our value in step 2. To find our lower endpoint, we subtract. To find our upper endpoint, we add. So this gives us the interval 0.27 to 2.11. This tells us that we are 99% confident that children with high sugar diets will have between 0.27 and 2.11 more cavities than children with low sugar diets. Now notice, these are positive numbers, right? So our range of values is positive. Since we're looking at subtraction, the only way we get positive numbers is if this number is bigger than this number. These numbers are averages. They're representing the average number of cavities in children with high sugar diets and children with low sugar diets. So this tells us that the high sugar diet children will average more cavities, okay? Again, if you have any questions, email me or post in our Canvas discussion board.